I
do
love
like
our
the
new
music.
intro. It's so good. The fact
Yeah.
that they gifted us that makes my life just 100 times better than it was before I had that.
Yeah, it's I like the metal aspect of it. My problem is I'm jumpy, so I click go live and then like I automatically click the thing. It's like just take your time, kid. Pump the brakes.
5 seconds.
Yeah, take it easy.
5 Mississippi.
Yep.
Yeah. Like I keep threatening one of these days I'll actually reinstall OBS and like add a lead and add our graphic at the end and do the things. Maybe I'll do that while I'm on medical leave. So that takes us to our announcements segment. Just real quick. So announcements. Next week we actually have a guest. We were supposed to have a guest this week. Unfortunately, our guest is located in the Middle East, so he needed to postpone. So Natan will come on and tell us more about like all the great things that have come to Holmes GPT since we last looked. Hopefully after KubeCon. Next week we also have a guest. We're streaming back to back. Just ended up being I didn't want to cancel another stream, so we replaced today's topic with something loosely related to GitOps. So next week we also have a guest. He's another Red Hatter. His name is Eric. He's going to I forget the topic. I'm so bad. I was up until 1 a.m. working on my demo. I think I adequately sacrificed to the demo gods for today, but we'll find out in a minute.
Yeah.
After
Let me see if I
KubeCon,
can find it. Because it's Himmerlich, right? Eric Himmerlich that's coming on.
But I didn't actually put in the email to you what the topic is because I'm not a functional. I checked that already. Yeah, I'm dumb. So my husband, what did he call me? My husband called me the stupidest genius he's ever met, I think is what he called me the other day. I was like, yeah, I feel like that's pretty good. I thank you for your forgiveness. I appreciate that because Lord knows I need it. Anyway, so other announcements. So after guests, we have KubeCon. We'll break for KubeCon. I suspect we will stream once, maybe twice more. And then I have another surgery, not on my shoulder this time, but another surgery, kind of related to the same accident that caused me to go out for all that time on my shoulder last year. Another surgery that I have to have, and I'll be out for a few weeks again. So we won't stream. We may not stream at all in May, is really what I'm saying. Between mid-April through May, we may not stream. So public calendar will be kept up to date. Johnny can stream without me if he wants to. He's always welcome to do that. So the public calendar always remains our source of truth of when we will be on the air talking about nerd stuff that we talk about. Right. So that brings us to today's stream topic. Longtime viewers, anybody who's listened to me at all for the last 6 months ever knows that I have been working on a book with some co-authors about AI observability and operations. And that finished. But while I was working on it, one of the things that we talk about in the book is like making sure your AI implementation is accurate and reliable so that you can trust it. And so the how of that is kind of cool because it's a process called natural language process scoring. There's a few different models for this. So I'm gonna put into the chat here this great article from Geeks for Geeks on Blue versus Rogue. And then I will share my screen, which I have not done on this stream in a while.
Go. Yes, and wait. Wait till you get to the admin side of the UI. It's amazing.
It already looked so different when I joined just the studio part. I hate it when Restream changes our user interface. I'm old and cranky. Don't change my user interface on me. I just realized I don't have my AdBlock Plus extension installed for my work Chrome profile. Oof. All right, this is fine. And obviously I do a ton of stuff on Azure because I get all these Azure ads. So there you have it. So this is like a really great breakdown of Blue and Rouge. Blue and Rouge are not the only scoring systems. There's also BERT, which we will show. Meteor is another. I'm not going to read the whole thing here. Here's the math. Basically, basically what it is it's evaluating, and this is actually literally evaluate is the Python library. It's evaluating the correctness of a model's output based on like benchmarked expectation. So it's a very like straightforward comparison of like if you're writing a bug, like actual result versus expected result, right? And then you get these scores that that tell you kind of like how did it do, right? So the scale is like from basically 0 to 100%. Blue represents it as like, you know, from 0 to 100 in terms of its numbers. Rouge, I always want to call it rogue because I'm dyslexic. Does like from 0.00 to like 0.1. So as it points is 0.1. It's like that's like the best score. And then I don't know if this article has it. I read through so many articles on this before I wrote my own.
The quick question is,
go ahead.
Sorry about that. Is this like where, like when you do like a RAG model or something, like a retrieval augmented generation, whatever? Is this where it's like how helpful was this? You know, like where you click on the 1 through 5, or how accurate was the content that you get back? Where you actually give it the score? So you as a human are grading it, or is this all automated where it gets it's grading based off of like what the request was and what the actually output?
Yeah, it's all automated.
Okay.
So it's not that human score, but actually it's interesting that you mentioned RAG because Blue and Rouge are originally applied to RAG. You can apply them to LLM, and that's what we'll show.
Okay.
Well, we'll do like a rough example of it. But it actually was originally for like RAG and CAG, cache augmented generation. So yeah, that's why there's more. So if I go to, let me see if this will automatically change my tab. No, I need to do it. Right. So if we go to like more models for scoring have developed, and I'm having the worst lag on my end, so I apologize. More models for scoring have developed. There's one called Meteor. We're going to look at BERT because I did a bunch of assessments on these models and like tested them out against an example response from my LLM that was like, I'm happy with this response. This is what I wanted it to say. And I found that in terms of like how happy I was subjectively versus the objective measurement, Rouge and BERT were closest in their objective measurement to my user satisfaction. And so like that's kind of an interesting note that the subjective happiness with the response may not mathematically match the expectations of the automated assessment. One of the and in the example that I'll show, I'll pull up the code in a minute. Let me actually make sure I actually have VS Code open. One example I'll show the prompt. So we're only evaluating responses, right? Like the prompt is not included in this test that I'm going to show. The prompt included optimize your response for tokens so that it would respond with fewer tokens. So with that optimization, right, then the summary, and BERT specifically looks for like how successful was the summary, and Rouge sort of does the same thing. The summary I was very happy with because it was concise and actionable for me as like somebody in like reliability engineering. It didn't score very well. So kind of have to understand that your benchmarking and your scoring needs to have that, like you were saying, like how happy with this are you is like a piece of augmentation that you need to bring into your like evaluation loop on your implementation of AI so that you know what your real like benchmark and thresholds is. When we're doing things like IT operations, our prompts and responses can be very predictable and repeatable, which is an advantage that we have over things like a chatbot where your prompts and your responses hopefully can be fairly predictable, but like your prompts are going to be like very unpredictable. When we're setting things up for like automatic like troubleshooting, investigation of an alert or whatever, like the prompts are always going to be the same. So we should have a really good understanding of what the responses ought to be. So that's like a really big advantage for the use case of like AI in operations. I do actually have my VS Code open already. Look at me go. I'm so happy with myself. And so, yeah, when I evaluated quite a few of them, and I decided that I felt that the BERT probably was the best for the use case with Rouge in number 2. So that's what we're going to show. And then we're also going to show another way of approaching the problem of scoring, which is by using an SLM, a small language model, to evaluate the output of an LLM. And we're going to use a tool called DeepEval for that. But we'll go into that in a minute. Let me get through my first examples. Where did I put these? These are in here. Select. And now I have to make my VS Code very big. I have a big monitor. I have one of those like 49-inch, like ultra wide curved monitors, which is great. Nice. And then my utilization of that is 100 tiny windows that I transition between.
Yeah.
So every time I open a new instance of something, it opens like yay big, because that's how I actually like it probably looks like insanity to most people. But it's what works for me. So here we go. And now I'm going to change my screen share. If I can figure out how. Here we go. Window. Share we go. All right. And that is maybe readable. How's that?
Yeah, that's better.
Okay. So let me just walk you through what I did here. So I had a kind cluster set up, and I had, what did I do? I don't even remember what I did. I don't remember how I broke it. There you go. I did this a little while ago. I had a kind cluster set up, and I basically broke it. And so the nodes were not ready to do what was needed. And I didn't paste all of the logs in, because that would have made this code sample like unusably long. And I was lazy, and I didn't like put it all into a file and have the code read from the file, which I did do for the DeepEval version of the demo that we'll see. But basically what we have here is we import the BERT score Python module. And then I just give it a reference and what the model like actually did. This was the model, because I was looking for a summary. This is the model's, it's the response, but the response was a summary. It's just how I decided to name it. The example code will show you like reference prompt or whatever, and like model response or like whatever. It's on the Geeks for Geeks had a great code example too. So this is also, the libraries have this examples and just available. So you do what you want. But yeah, so that was the log. You can see if I keep scrolling, this is the log I gave it. This is the response that it gave me back as like, here's a summary of like the log, much more readable, right? Kind 2 and worker kind 3 had their ready conditions set to unknown. And then I just base case, like exactly as the documentation said, be like, all right, score this, right? So if I do terminal, I'll do this. We're going to do source, dang it. Well, it did the thing. Auto did it thing. That's why it interrupted me. Sweet. My virtual environment kicked on. That's what I wanted in life. And we're just going to run this. Python. I should say that the BERT score package is large. So if you're doing these things locally and installing them on your machine, I forget how many. It's like it's several megs, possibly. I think it may even be some of the stuff can get up to being a couple gigs. So this is not a small thing to have in your on your machine ready to go. So like just kind of be aware of that. Make sure like check your system requirements before doing things like this. But yeah. Anyway, we can ignore this. That's like it says, can be ignored when loading from different task architecture or you know, basically I didn't do like a really like amazing implementation that would have gotten all of this information in there. And so just ignore it. If you need all that, use the docs, do the thing, etc. But what I did get is these elements of the score. And remember, approaching 0.1, just like with Rouge, is like ideal. The documentation says that basically like a production ready system would score at 0.8. That would be considered like a good score. And below that, there's room for improvement. So this says room for improvement. There's a terrible prompt in here, I will say. And like there's a terrible reference, and there like what is it like? What was it asked to summarize? And I asked it when I asked it to summarize it, I actually also told it to optimize for tokens in its response, which it did. So a little bit in the prompt is going to influence the success of your scoring, or like the how highly scored it is. I think that that's acceptable. I think this is like, I was happy with this. Like it gave me what I wanted. It gave me what was actionable from the prompt I gave it. As you are experimenting or benchmarking your own systems, you're going to need to kind of evaluate how good was your prompt really. And then you'll need to also evaluate the response. And then once you kind of have like an understanding of, based on your prompts, where your scores tend to be in your system, then this becomes the metric that you start looking for on your like regular testing or whatever. Like schedule it on a cron job or something. Have it, you know, evaluate saved prompts and responses for what and you know, once a week or what have you, once a day, and see if the scores are like really drifting away from what your expected benchmark was. So if we go to the Rouge example now, kind of the same thing, right? We're just basically saying, hey, what was it given? What was the summary it gave me based on the input it was given? And then what is the score? I know there's a like little run thing. I know about the button. I just never used it. I do know about it.
But this is more natural. This just feels better. I use VS Code the exact same way. Like I could do all the stuff in the UI, but I just like the shell better. So
I just like the shell. I just let me use my shell and move on with my. I actually almost never use the terminal in VS Code. I am doing this for illustrative purposes, and it feels so weird.
Yeah. It's like using the OpenShift UI, right? Where it's just like it's beautiful, but it's wrong.
Yeah, it's beautiful, but it's not for me.
Yeah.
So this is the same exact reference log, same exact response, right? And literally no difference there. This is with the Rouge scoring system, and this is the score. And so on their documentation, they basically say that about 0.4 would be a production ready system. So this scored much less than 0.4 in terms of like if we look at just like the F1 score. So that is, you know, it's again, and it's just the link I shared earlier, like it has all the math, but then and you can go like very like much deeper into the evaluation framework to understand like how they get to like what is considered good. It's kind of like they're looking for exact matches on text and like how like what is the frequency of occurrence of exact matches on text. I also suspect that a much shorter reference will result in a much lower score versus like if I'd had much more in there, and then there would have been potentially like a longer response, it could score better, right? Because there's just an absence of opportunity,
right,
to hit certain thresholds. So I haven't played with this in all of the various like capabilities. And again, I had this particular demonstration. I needed it to be something that you could see easily in this format. So it is very like narrow. So just be aware of, again, what did you give it? Was what you gave it useful? And were you happy with it? Like, so again, I was really happy with this response. It was actionable for me. If I had just if this had just been like, help me understand what's wrong with this cluster, and like it went to read logs, it was like, hey, nodes are not ready. That's immediately actionable for me as a reliability engineer. So,
So can I ask you something where in your workflow, where does this fit? Right? Like, cause this isn't something that like as somebody that's writing code or as somebody that's interacting with this model, right? Like in this case, right, we're passing it logs and stuff like that, but like where does this fit in like in like the whole ML ops flow? Is this stuff like, hey, people are using my model, it's using the queries, it's saving the information, it's saving what it's like what it output, and then you're running this against that and at the end of the week to get like the how accurate was my model over the course of time, or is it like does this run every time somebody interacts with this and then it builds up on the score? You know what I mean? Like I'm having a hard time wrapping my head around where it goes.
How I would do it is when you're doing your implementation, you're going to go through an experimentation phase, right? To determine like what is your model ready for, like what does it see, what does it have its sea legs for, right? So in this case, like let's just say like the use case is like I'm using probably Holmes GPT to automatically investigate Prometheus alerts, right? So I have the ability to you can force feed a Prometheus alert, right? Because you can just copy, add in invented data and like, off it goes, right?
Yeah.
Or you can, like what I did, I force broke my environment and then I prompted it and got a response. So you're going to do some experimentation, right? This is like you're in during the implementation of like how you're going to do like what is this actually gonna be able to do so that I have an automated flow. User manually doing prompts is a different one, and that's fine. You can also mimic that, but you're probably not putting something out and not telling people how to correctly use it, ideally. So during you're the implementer of an AI ops solution, this is like you're going to be experimenting.
Okay.
During your experimentation, you should be benchmarking, right? Just like when you're writing software, right? I'm writing a new piece of software. I need to benchmark it to know like how much CPU does this need? What do I tell if I'm on Kubernetes? What do I tell Kubernetes for the requests and limits to be on CPU and memory, right? You need to do this benchmark. It's the same philosophy of like, okay, I've got this thing I'm implementing. I need to benchmark its behavior. So we get these scores as a benchmark. And once we are like, all right, this is what and this helps you to design your prompts as well. So there's kind of like a few like birds in this with this stone, right? Like you can get your prompts much better that you're getting to be feeding to your AI ops system by evaluating how its responses score versus how happy you are with them. And you can also, I always recommend, it knows how to prompt real well. AI knows how to prompt itself real well. Just ask it how to the prompts ought to be. It will do a much better job than you trying to sit there and absorb all the knowledge of how to do a great prompt and do it yourself.
Yeah, I did that with Claude. Yep. Same. I was like, yeah, give me a good prompt for this. And it was like, yes.
Yeah, exactly. And then our prompts, because especially if our prompts are, hey, investigate this, really repeatable, right? You've got to plug in some variables like, what is the name of the pod or what is the name of whatever, but like the rest of it is all the same. And it's like, you can give it context and instructions, et cetera with it. Right. So then after it has what it needs to review, then in this case, I just gave it a log, like summarize this log file. Then, it comes back with its response. So you can store these responses, the requests and these responses, right? And then, like I said, you would pull them into the file as variables and do the test. And like I said, you do the test initially for the initial benchmarking, and then you should be observing your AI to like it's going to eventually hit an error. It's going to eventually hallucinate. The models they're supposed to get better and better, but I just saw a white paper from, I think it may have been OpenAI itself, saying that the models are actually hallucinating more now than they were initially. So you have to observe your implementation on an ongoing basis for correctness. That's really important, right? If you're going to trust to something like this, you need to have a way of like verifying that it's doing the right things. So I recommend some human review as well. Just be like, okay, how did it respond? Did I like it? Having humans initially working like explicitly with the thing to like in an interactive mode to kind of like provide that like user feedback of like, was it good? Was it not good? Is an important element of your implementation details. But it's a little bit like how that's going to look, how you're going to do it, what your staffing for that's going to be is very like dependent. This is something that like go copy this code off of literally any of the various examples where this exists and you can start implementing it, right? Again, I was really happy with the response. I also told the response to optimize for tokens. When it optimizes for tokens, it's going to sacrifice some of the other things the scoring model is looking for, such as exact repetition of words. It's a low score. Subjectively, it's a low score. Objectively, it was a good response. It was actionable for me. So, I would say, given like this alert I asked it to investigate, or this situation I asked it to investigate, this response it gave is good. My benchmark now is 0.22 for accuracy against this particular scoring model for this AI implementation. That's fine. Then if that drops lower than 0.22, and keep in mind, since it's such a very small like number space, like probably like 0.20, I might want to go like, that would be a cause to like go alert the humans.
Yeah, just regression at that point, right?
Yeah, it's a potential regression. It also could be that, the systems changed, or the, something changed that wasn't like adequately accounted for in what the expectation given to the scoring system was, and we need to change that. Just like any test infrastructure, you need to maintain it and keep it up to date. Otherwise, you can get false failures. But yeah, so this would be my benchmark on this particular one. Again, I think at the end of the day, the BERT scoring system was the better one for this particular implementation of AI. I did not run this. This is the Meteor scoring system, which I didn't even pull up a reference for on my web browser. Let me see if this runs. I didn't test it. There we go. This is the Meteor score, 0.04. I don't remember the scoring. Like, I don't remember the scorecard. I believe this scored very low. I'd have to go look again. But again, that's probably like, I'm happy with it, so that's probably fine. Just again, you have to know it's an objective tool, but there's that subjective element of, okay, yeah, it didn't score well, but did it give us what we needed? Did it give me something actionable? Did it do the things I needed it to do? Again, a longer prompt, a longer response, I imagine will drastically change these numbers compared to this example. Yeah, Meteor approaches, thank you, Johnny. Meteor approaches from 0.0 to 1.0. So this is a really low score. It's why I don't recommend it, but I did test it out, and so that's why the code is here. Trying to make sure I'm not missing any questions in the chat.
No, I don't see any.
Cool. I'm gonna swap my share again to DeepEval. We're gonna run out of demo before we run out of time at this rate. That's never good. I don't want to be done that early. That's just awkward. All right, let me explain DeepEval real quick. DeepEval is cool. I will give a lot of credit. So when you're publishing a book with a publisher like Pachter O'Reilly, there's a engineering peer review that it goes through with people who you don't know that they recruit to do their peer review. One of our peer reviewers was like, I would have expected to see this, and I had not come across it in any of my independent research, actually. So I'm super grateful to our reviewer for that. This is now included in what we covered. I learned a lot about it. I stayed up until 3 a.m. a couple of times playing with this. The pattern was something I had identified. This actually is just an implementation of the exact pattern. So what DeepEval allows you to do, it basically is a unit testing framework. So it allows you to unit test your prompts and responses and correctness using another language model. So what I recommend is a small language model to evaluate correctness as opposed to another large language model. The one I will use for this demo on my machine is actually Gemma. Gemma doesn't really, it can run on CPU instead of GPU. So in the book and on my personal machine, I used Tiny Llama, but Tiny Llama wouldn't complete on my work machine because my work machine has no GPU. Thanks, guys. And so Gemma Gemma was able to replace it. It works great. So you import deep eval. So like a pip install, actually pip install -u, capital U, deep eval. This is also big. This is not, these things are not small. Like they do run on a developer laptop, but they're fairly large. They take a while to download. And then you're also going to have Ollama running. Well, for my example, you have to have Ollama running. Theoretically, you can give it an API key and have it go off to like ChatGPT or something else. But yeah, you're gonna need for what I have Ollama running, and Ollama is serving API at a port. It's, I forget which one it's in the code. We'll see in a second. And then Gemma will do an evaluation of correctness for a given prompt and given response. So this is really cool. They also, DeepEval like pre-exists LLMs. So a lot of the capabilities and so forth in here, the documentation still has some, I would say, room for improvement. It's very, very, it's obviously a new capability of DeepEval. DeepEval, in terms of like, if you look at like RAG and especially like the RAG use cases, far more fleshed out. They've been doing that. It's been used for that for much longer. So this is an open source tool. They do actually also have an enterprise offering. I've never used it. I assume it's good. I have actually no idea. The open source thing works just fine. Did everything I needed it to do. So yeah, that and so like I said, this can run, basically just plug this into your unit test framework. Whether that is like you're running it locally or it's built into your CI/CD systems and you have that kind of capability on the CI/CD systems as well. Let me switch again back to my VS Code. If I can find it. There's VS Code. This is the correct one. And now I will pretend like I know how to use the user interface for the restream.
Mommy!
I know, right? Somebody save me. I don't know what I'm doing. Okay, let me make this bigger. Is that readable?
Yes.
Okay, great. I love that for me.
Well, it's readable to me, and I'm blind, so hopefully everybody else can see it.
Oh, good. All right. Well, if somebody can't see it, the code that I'm showing here is all available in the repository for the book I wrote, which is public. Do I have a link immediately handy for that? No, I don't, actually. I should have I should have done that. And how
dare you even ask?
And how dare you even ask? Rude. I'm pretty sure if you just Google it, it'll come up. Anyway, I could probably do a git show origin and grab it in a second. So this is a horribly named file, by the way, but it is, since it is a unit testing file, it does need to start with test. And then I just named it DeepEval1 because it's a demo and not like, I didn't want to have a really, really, really long test name. And as we all know, the two hardest problems in software engineering are naming, cache management, and off by one errors. So there you have it. Here's my naming problem. Right, not showing you in the setup is all of the like I did an installation of Ollama. It needs to be at 0.5.0 or newer in order for this to work. Just kind of, originally it didn't work for me, and it was like, oh, because I had like one of the very first versions of Ollama on my machine, and that is why. And then so once I replaced that, it was good. It worked. It did the thing. So again, this is a unit testing framework, so you notice there's no like if main whatever down here. Not required. You can run it with PyTest, or you can run it with the DeepEval command. I'm going to use the DeepEval command here just for funsies. So after you do the import of DeepEval, which is just that, The README, by the way, has like all kinds of information, which I actually still haven't looked to make sure it actually renders appropriately. So if you notice it doesn't, that's because I pushed code and didn't check. I'm notorious for this. Anyhow,
yes.
For READMEs, I am. For demos, I am. Not for like real code. Somebody would not approve any of my pull requests if I was that bad. But regardless, so I do have Ollama downloaded. I have it installed. Ollama start. Actually, the install script now will automatically start it and have it serving on the port. That is an improvement over earlier versions that I quickly saw. So used to have to like start it and then close the terminal. It would keep running in the background. Now you don't have to do that. It's just handled as a background process for you in the installation. If you do the install script that they have, again, that's in the requirement. That's in the README that I very briefly showed. Temperature is 0. I don't want it to have any like room for. I don't want it to give any grace for errors. Basically, that's what that means. It's like what's your temperature for like risk? I guess risk is not the right word I'm looking for, but that's what that means. So here it's like, no, we want it to be like as accurate as possible, like utmost confidence.
Be harsh.
Yeah, be harsh. Asking DeepSeek to count r.txt is the this is the file here. This is the response we're evaluating. Fun fact, I show DeepSeek not succeeding in this in the book, and then I also show it succeeding. I brute forced it into failure by running it on a machine without sufficient resources. So I identified that resource starvation can cause errors, and that's very, very fun for me, who loves to know how to break things. Very important for you to know who may be trying to successfully use things. So check your system requirements before running things like DeepSeek or any like real large language model, like above 10 billion and up is like a large language model. 10 billion below is a small language model. Architecturally, it's the same. It's just like amount of data and data parameters. So, right. So DeepSeek, given the prompt on a machine with appropriate GPU and therefore VRAM, successfully did this very well. Without enough VRAM, spiraled for a long time. It was really spiraled or got it wrong. It was very fun. I had a great time with that, and I highly recommend it. I do recommend doing this. Play with an LLM on a system that is under resourced so that you can see the behavior, so that you can be aware of the behavior.
Mm-hmm.
Because that could be something that if you're implementing AI for operations or something, you could actually legitimately run into, especially in like multi-agent situations, if you end up with like the same model on the same host somehow. So yeah, there you go. This is the response we're evaluating. I didn't include all the thinking. Again, that was just for clarity of the reader. The very first time I actually had this evaluated, I did include all the thinking. It just didn't make a difference in the evaluation. So from our actual file, this is the prompt that I'm actually giving to the small language model. And again, I probably could have a better prompt in here. This one worked fine. A longer prompt will result in like probably more accuracy, but also small language models are a little bit more delicate with their context. So you do have to balance that because otherwise they can get a little bit more prone to errors.
So is the reason why the larger prompt is better because it's got more to kind of dig into? Is that what it is? Like it's just got more. Yes. There's more surface for it to use. Okay.
Yes, that's precisely it. Correct. But again, this particular use case that I'm like where with the demo here is all incredibly simple. So I didn't need to have a long prompt. This is the prompt I gave DeepSeek. I did not need to have a long prompt for DeepSeek because this use case is very simple. And when it has appropriate resources, it understands that capital R and lowercase r are the same, even though computationally they're not the same.
Right.
When it's under resourced, it can't figure that out. It's very fun. 10 of 10 recommend. Really, I really cannot. I had so much. I spent hours while recovering from my shoulder surgery playing with LLMs on deliberately under-resourced machines. At a certain point, it just became a game.
Yeah.
It was really. I love breaking things. It was very fun for me to
How far
learn
can
and
I go?
observe. Yeah, what can I get this to do? I
Mm-hmm.
got hallucinations. I got all kinds of fun stuff, and I had a great time with it. It made my day. It still makes my day. It still makes me smile afterwards that I broke it successfully. This is again, started my career in quality engineering. Breaking things successfully is like who I am as a person.
It's what I do.
It's what I do. I like to understand how things fail, and it makes me a good reliability engineer, I think. But anyway, so right, what are we doing? We're looking for correctness. This is just like the name of the test. This is the criteria. This is this is what I'm prompting the small language model, in this case Gamma, to do. So this is a prompt. This is the things. And basically it's like 50% is like considered a pass. This is like my threshold for like, is it good? It's like should be 50% or better. I don't think that's fine. I saw no reason to change that. The test case, right? This is the actual case. This is that I prompted DeepSeek with. The actual output, again, this is the output that I had us, right here. Def output, blah. That's this. So that's that file we showed. And this is expected output. Again, it's like actual versus expected, just like if you were filing a bug report. So I just made up what I would roughly expect it to say. And then we will run this. This is not the fastest thing to run, by the way. So again, you can run these with PyTest if you just want to include it in your general suite of unit tests as just another thing, or like run it with DeepEval. I'm going to run it with DeepEval just so that you can see that that's an option. Most people who work in PyTest understand how PyTest works. Also, the output looks the same either way. I'm not going to lie. Let me see if I can make this a little bit. Oh, you can actually see the old test. Ta-da! And not the greatest. I recommend actually like having this output saved somewhere. Dang it. If you can. There we go. Hang on. Sorry. Here's this table. Here's the score that it gives it, right? And this is actually the reason. So this is actually the response from Gamma on why it gave it the score. So it actually gives you the reasoning for the score.
Oh, that's cool.
So yeah, it's like the inclusion of the case sensitivity discussion and explanation of why the answer is typically 3 is extraneous and deviates from the core task of simply identifying the occurrences of the letter R. That's a great score and great reasoning, right? And helps. So this was my kind of favorite thing. I suspected you could do it, knowing that there was a library that automatically like just kind of helps you do it through your unit testing with DeepEval. Was the favorite thing I learned during this process for this book. Again, major thank you to our technical reviewer there. He does get credited in the front of the book, so like
Nice.
You'll get to learn about him and his background in that. So anyway, yeah, there you have it. You can actually realistically build an entire pipeline out of this. And there are tools for building entire pipelines that I did not fully go into. But that is the kind of the intention of including of DeepEval is actually having it in your CI/CD pipelines. Again, not small. I think Gamma is a couple gigs, maybe not that big. All this is a few gigs, right? By the time you put it all together, you've got like five-ish, I think, gigs of stuff you've got to have. Computationally, like Gamma runs on CPU. So computationally not very expensive, but it could really save you from having, having a problem. So where this really starts to matter, if you're using a vendor AI, right? Your vendor is doing this stuff too. right? They're doing this evaluation too. So they're going to be working on making sure that the model is correct. If you're doing your own fine tuning, fine tuning is good, but actually, like, if a mistake is made, an incorrect data set is introduced, just by the nature of some of the delicacies around it, you can cause catastrophic forgetting, which is kind of a fun thing. Cornell University has a great paper on how to recover from catastrophic forgetting. I wouldn't recommend trying. I would recommend redeploying from ideally a checkpoint, because you can do checkpoints on your models and like basically be like, all right, this is a good point, kind of like snapshot this like point in time for it, and then keep your tuning going. But yeah, basically I would like redeploy either from the beginning if you don't have a snapshot that's more current, or like from a snapshot. I wouldn't try to recover from catastrophic forgetting, although it is theoretically possible. So like the Cornell University put out a paper on that. It is very dense. It's very dense to read and get through. I would say I read it. I don't think I could say I understand it well enough to explain it to you. I would just tell you probably don't. just don't even. Just start over. It's faster, so much faster. Especially if you're not like from scratch building up your own model, right? Which I don't think most of us are going to be living that life. If you do live that life and you're watching this stream, I have questions for why you're here, because you're probably smarter than me. And also, please come on this stream and teach us. Okay, thanks, bye. Anyway, but yeah, so this will allow you to, one, kind of like maintain the confidence in whatever you have in use. If that is a vendored, model with some additional like skills or something you've given it, that. If it is a model that you're hosting locally and you've done some fine tuning against, or just augmented with skills and MCP servers, that. What you want to do is make sure that what you have is running reliably, is behaving as expected. And like, that note, like, hey, it has extraneous information. That's actually good, because that catching that can help you with your cost management, right? There's that whole economy of tokens where if you're sending things back and forth to, ChatGPT, then like those tokens cost money. Also the responses, like tokens are used for the context, which is kind of like the memory of the session the model has. So its own responses fill up that context. And so the more it has in its context, the more opportunity for things like bias and errors you start to have. So by optimizing for tokens and saying, hey, just give me, like, if I had said, output your response just as the number, nothing else, then I may have gotten back only the number 3, which would have been correct and very minimal in terms of tokens. I actually don't know how many tokens one number is. Probably a fraction, because tokens are like, one token is 4 characters. But anyway, there's all these things. So doing the evaluation, like, you want to evaluate your score, knowing your score is good. Having a good score is, great, but may not represent satisfaction. So you have to kind of combine that. What it was the human element of it, what was the machine element of it, to kind of get a final picture. So you have to mix that objective and that subjective. And again, this was kind of like my favorite way of doing it, was having the small language model evaluate the large language model. You could do this with another large language model, by the way. You could. It's computationally more expensive. You will need some GPUs. Again, my personal computer that we ran this on does not have a discrete GPU. It's got lots of RAM though, lots of DRAM, so like 61 gigs or whatever. So that's why this ran so fast. These are just the patterns though. These are the things that we've identified that we know work and help you to have a successful, observable, reliable AI implementation. Do with that information what you will or will not. I finished 10 minutes early, Johnny. I got nothing left.
No, it's good though. I mean, like I would have never thought about like the unit test aspect of it, like, or like even like measuring the prompts. And I guess maybe not that I would have never thought about it, but I just never really thought about how it was done. You know what I mean? And so then, like, for me, like as I'm watching you go through it, I was like, where would I even do this at? But it makes sense when you're saying, yeah, you do it. It's very early. So it's just part of your development and stuff like that. And before you ever roll it out to production, like you're gonna have all these benchmarks and things like that. So
Yeah,
yeah, it's
it's
cool.
a quality gate. It's really
Yeah.
a quality gate. You need to know that what you're putting out is seaworthy, especially in operations, because operations, if you're giving something, ideally a non-human identity with a lot of restrictions, but access to production systems, you kind of need to make sure it's gonna work correctly and not be
Yeah.
dangerous, right? The news is like, not the news, like my news is filled with like horror stories of like, oh, open claw took out a production database, stuff like that, right? You
Yeah.
see it all the time. How much of it is real versus made up stories, I don't know. But it's just like, it doesn't have to be that way, because before you send it off into the wild to start doing things, you can validate it for the things you want it to do upfront.
Mm-hmm.
And I think that's kind of one of those, there's the excitement about the space. There's the like, the almost feels like endless possibilities, right? Because with automation, you're kind of restricted to like, what do I have time to explicitly write in to my automation? With AI, it's a lot less of that. But the space is still risky because automation is very predictable. It's always like this or that, right? Very binary. Your LLM can decide to do something that is not in the automation. Now you can give it the automation to run and say, hey, you're going to investigate this alert and then choose from these automated actions to run, or you're going to notify a human, right? And it can do that. You'd use an instruction files and some guardrails to make sure it doesn't do anything else. Instruction files are your friends. So the where was I going with that? Right. So like you have that kind of almost that chaos element where you don't really know what it's going to do. And you need to know, like, if I did fine tuning, how do I know my fine tuning worked? You have to, again, check, right? You have to test it. It's another piece of software. It's another application. It's another capability of your tech stack when you implement it, right? It's not a magic box. It's not a genie. So a lot of basically all of the same patterns we use for anything we develop and deploy apply. You just have to leverage them. You just have to remember they're there and do them. And like, yes, it's exciting. And that experimental phase is very fun, especially when you're breaking it on purpose, right? But having it take out a production database, not fun, right?
Yeah,
Nobody's having a good time with that. No one's having a great day with that. So it's like, I just have this very, like, my approach to this is incredibly pragmatic. Figure out what is actually, like, what do you really want it to do? What are the use cases it really solves? Break it down into that. Start setting up the implementation of that and then validate and test it. And then you can, kind of start to reduce the human oversight and go start spending your time on other things. And I think that the multi-agent approach of like using multiple agents is probably a good idea, of like you start having agents that are like really like tuned for their various like very specific tasks. For fine tuning, which we're not going to go deeply into here because I do not have that kind of time. A large language model takes longer to tune than a small language model. So something like Tiny Llama or Gamma 3B, if I wanted to like bring it into, shamelessly plug, OpenShift AI, right? If I wanted to bring it into OpenShift AI and start fine tuning it, right? That can be done in a matter of hours, depending on how much data I have available, what fine tuning method I choose, and what I'm seeking to get out of fine tuning. So a small language model applied to a very like narrow task set can outperform in terms of speed and accuracy a large language model, and it'll be computationally much less expensive to run. So that's kind of cool. However you decide you want to like do an AI ops implementation, like natural language process scoring, testing, evaluation, benchmarking, that needs to go feed into your process. And then observe it, right? Continuously test in production and observe in production, basically, just like you would just anything. And it's software at the end of the day. That's my rant.
My dog is losing her mind that I'm not paying attention to her right now. I'm like,
which dog?
It's the Roddy, and she
of course
is
she is.
a big
They're
baby.
babies.
She's over here barking at me, and I'm like, dude, be quiet.
That's amazing. Well, I tell you what, it's 4 minutes to the top of the hour. I honestly can't think of anything more useful to tell people than I've already told them. I'll stop screen sharing is what I will do. And we can just say our goodbyes.
Yeah, awesome. So
Awesome.
next
All
week,
right.
and then KubeCon, right? And then
Next week, and then KubeCon, and then sometime we'll stream again, and then I'll be out for a while, and we'll pick back up towards the end of May.
Okay, awesome.
Public calendar will be up to date. Thank you, everybody, for tuning in. You all were present, but very quiet. We see how many viewers there are. There was like 16 at one point, which is a lot for a stream I forgot to promote in advance, honestly. No questions, which is always disturbing. It always makes me question if I am making sense or if I'm confusing people.
I thought it was good. I was able to follow along, and then yeah, it sparked questions for me. So
There we go. There we go. All right. One person learned something useful today. It was Johnny, but that's fine.
yeah, it's okay.
It's okay. All right, great. Until we talk next week, guys, choose your tech debt wisely. We'll see you soon.